Hey guys, welcome back to the channel. Now a while ago we brought you a video called How Much Does a Heat Pump Cost? And this video primarily dealt with the cost of installing a heat pump. So how much it was going to cost you to get your heat pump into your home working effectively. This video today is about how much your heat pump is going to cost you to run. So how much you're going to be spending on your annual bills once you have installed the heat pump. It's going to get a bit technical. We are going to look at some maths quite closely, but please don't let that put you off. Do encourage you to stay till the end, because by the end of this video, you're going to have a very clear idea of how to calculate the likely costs you're going to be incurring on a yearly basis with your own heat pump in your own particular situation in your own particular house. So let's dive into it. Now the first thing we need to do is to figure out how many units of energy are required per year to heat your home. In the UK, the average home uses about 16,000 kilowatt hours. Kilowatt hours is the unit of energy that we talk about. It uses 16,000 kilowatt hours for heating, hot water, electricity, that kind of thing, lighting, whatnot. The problem with this is it's not very accurate. It's a very generalized figure. So to get a much more accurate understanding of what's required for your home, we first need to figure out how much heat your home loses. Now, the Rolls-Royce gold standard of doing this is to get a personalized heat loss survey, which is absolutely what we would recommend if you're thinking of installing a heat pump in your home. You basically have a dedicated engineer come to your house, look all over your house, the way your house is made, the kind of insulation, the windows, and calculate how much heat your home is likely to lose. In lieu of doing this, just to get a very rough estimation, we can use a table like the one that's appearing on the side right now, and this is going to give us a rough idea of the heat loss per meter squared in our home. Now, heat loss is expressed in watts per meter squared, and unsurprisingly, we can see that as the energy performance of your home deteriorates, the heat loss increases. So for a very recent new build, you could be looking at something like 20 watts per meter squared. But for an old leaky Victorian house, you could be looking at something like 85 watts per meter squared. So there's a big difference between the two. But once we have that watts per meter squared number, we can figure out the heat loss for the whole house by basically timesing it by the surface area. So for a 145 meter squared new build home at 20 watts per meter squared, we'd be looking at 2,900 watts of heat loss. For a leaky Victorian home of the same size, we'd be looking at 12,325 watts. It's then helpful to divide this number by 1,000 to get the kilowatt number, because there's 1,000 watts in a kilowatt. So for our new build home, we'd be looking at 2.9 kilowatts. And for our Victorian home, we'd be looking at 12.325 kilowatts. So now we've got the heat loss figure, and the next step is going to be working out the heating demand based on where you live in the country. Now, to do this, we use something called HDD, heating degree days, which is used in a lot of places, including the UK. And HDD effectively expresses how many days and how many degrees the outside temperature is below an agreed base temperature. So 1 HDD means the outside temperature was below the agreed base temperature by 1 degree for 1 day. Obviously, the more cold an area is, the more HDD days will be required to heat your home to a comfy temperature. So HDDs in the UK are published by the Met Office, and you can go there and you can look. There's a link in the article attached to this video. You can go there and you can look what the average is in your area. But as the UK as a whole in 2023, the average was around 1800. So we're going to use the 1800 figure for this particular working, but obviously you'll be able to get a much more accurate figure for your own area when you come to calculate your own likely running costs. So the heating demand for your home, all we have to do is take the HDD days, the HDD, and times that by the heat loss. So for our new build house, the mass is going to be 2.9 kilowatts times 1800 HDD, which gives us
5,220.
Now this is the amount of energy we will need to heat our home for 1 year. For our Victorian home, it's going to be 12.325 kilowatts, which was our heat loss, times 1800 HDD, which is our average heating degree days, and that gives us 22,185 kilowatt hours required to heat our home for the year. So now we know what the heating demand is, we can work out the running costs. What makes an air source heat pump so efficient is the fact that it uses less energy than it outputs. And this is referred to in something called the seasonal coefficient of performance. We have spoken about this before. There is more information on our website about this. But typically in the UK, the average seasonal coefficient of performance, or SCOP, of an air source heat pump is 3.4. So for every unit of energy it consumes, it outputs 3.4 in heat. So for the sake of this mass and this particular working example, we're going to use a SCOP of 3.4 to work out how much energy we're going to have to put into the heat pump to get out the heating requirements. Obviously, with your own heat pump, your own SCOP, you can work this out yourself. Again, you can tailor this example to your own particular situation. So for our new build home, it's going to be
5,220 kilowatt hours divided by 3.4, which gives us 1,535 kilowatt hours
to power our system for a year to heat our home. Looking at our Victorian house, it's going to be a total heating demand of 22,185 kilowatts. We divide this number by 3.4 to get the input required, which in this case is 6,525 kilowatt hours required. So now we have the amount of energy we need to input into our heating system to heat our home for a year. Last step of the puzzle, all we need to do then is find out how much that energy is going to cost us, and we're going to know how much energy, how much money it's going to take to heat that home for 1 year. Now, at the moment in the UK, at the time of making this video, which is December 2024, in the UK, a kilowatt hour of electricity, not including the standing charge, has been capped at, get this right, 24.85 pence. So if we look at the maths again, taking our new build house, we need
1,535 kilowatt hours of energy times 24.85 pence, which gives us £381.45.
That's how much we're going to spend to heat our home for 1 year. And for our Victorian home, we need to input into our system 6,525 kilowatt hours, again at 24.85 pence, which gives us
£1,621.46.
That's the amount of money we're going to have to spend to heat the home for 1 year.
Now guys, if you've been looking at this video and you have an air source heat pump yourself, you might think these figures look a little low, and there are a couple of things which we haven't included here. So the first of those is your standing charge for the meter. This is probably going to add on a couple of £100 a year to your bills. The second charge we haven't included here is your charge for domestic hot water, so baths, showers, that kind of thing. And typically for an average household in the UK, that's going to add on around about £500 a year to your bills. So you can start to see how we're now approaching those figures that you're probably used to if you have an air source heat pump installed yourself. So it's a lot of information in this video. We are going to leave it there today just because there's a lot to digest. If you have any questions or comments, please post them below. In the meantime, I do encourage you to go to our website, www.weloveheatpumps.com. We've got an absolute ton of information about air source heat pumps there, including more on running costs and more on the cost of insulating your house if you live in an older home. Now, if you like this video, please do hit the subscribe button. Please do hit the like button. It really, really does help us to get more information out there on heat pumps to the general public and to you guys. In the meantime, we will see you on the next video.